Okay, we are starting with number 8, which is a P over Q synthetic division problem. We have to state all the possible rational zeros. What that means is they want you to list all the P's over Q's. Since our coefficient of Q is 1, we only need to find the coefficients of P because that's, everything over 1 is just itself. So we got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. Those are all of our factors of 24 over 1. And now we just need to start guessing which one of these is going to work inside this synthetic division. So let's go ahead and just start guessing. 1, 1, 2, 24. What type of number am I hoping to get when all is said and done? What number am I aiming for, Skylar? 0. Now, who can raise their hand and tell us we've got 16 different options, but which options can I automatically rule out? Which options can I automatically rule out? Alan, what do you think? Positive ones, right? Because I've got all positive integers. I need to find some way to get negatives, start canceling things out. So let's just pick a negative number here. What do you think? Zoe, can you give us a negative number? Negative 2. Let's try a negative 2, see if it works. I'm going to bring this down and get a 1, negative 2, negative 1, 2, 4, negative 8. Did not work. So we've got to... So that means that 2 in and of itself is gone. Because remember, all the positives don't work either. Jake, what do you think? Negative 8, 1, negative 8, negative 7, 56, 58. Nah. Sorry, dude. So what that means is, no, I'm glad, because that means that positive and negative 8 is out too. You want to try negative 6, Jake? 1, negative 6, negative 5, 30, 32, too large. Kaylin, what do you think? Negative 4, let's cross that out, negative 4. So 1, negative 4, negative 3, 12, 14, nope. Kate, what do you think? Negative 3, 1, negative 3, negative 2, 6, 8, negative 24. It works. Now, once we figure out one that works, we write down x equals negative 3. Hey, you know what? Here's the thing, is that when you do P over Q's, just because you guess like 3 answers wrong, that doesn't make you any less capable. You're guessing, right? You're guessing, so don't worry about it. So x equals 3. Now that we have this is now x squared minus 2x plus 8 equals 0. Now, I have a funny feeling about this. I don't think there are any two numbers that multiply to positive 8 and add to negative 2. I'm trying to think. 4 and 2? No. 8 and 1? No. Okay. If I can't factor this thing, what should I probably do in this particular problem? Yeah? I could. There's something a little bit faster than that. Danny, what do you think? Completing the square. The reason why is because, Yael, this thing is coefficient 1 and this thing is even. Subtract 8 from both sides. X squared minus 2x equals negative 8. Add the box. Add the box. This is a negative 1. This is a negative 1. X minus 1 squared equals, that's 1, so this is negative 7. I'm going to take the square roots of both sides, so I get x minus 1, oops, darn it, equals plus or minus I rad 7, and I add 1 to both sides, so I get x equals 1 plus or minus I rad 7. Okay. No. X minus 4, x plus 2. Okay, so remember, this thing's supposed to be positive 8. If I multiply those two, I get negative. Right? Okay, so let's look at the next one. Are there any other questions on that problem? Hopefully not. Okay, good. All right, so let's move on to another problem here. That was number 8. Number 18. we are composing functions together. So it says h of x equals x squared plus 1. G of x is equal to x minus 1. They're asking to find h of g of x. Now remember, when you see this, I tend to convert this into h of g of x. That way, I don't know. I find that this notation here gives me a clearer indication of what's on the inside. In this case, g of x is on the inside, which means we're going to take this value and pump it into here. So I've got h of g of x, and that's going to equal x minus 1 squared plus 1. Raise your hands if you are not okay with what just happened. All right. So I'm going to FOIL this thing out. This is x squared minus 2x plus 1 plus 1. So I get h of g of x equals x squared minus 2x plus 2. That's how you do it. Take one, plug it into the other. I want to do a different one. I know it's not on the sheet, but let's do Let's do number 20. So f of n is equal to n squared plus 4n. And all they ask you to do is find f of n. Now, when they ask you to find a composite function of itself, sometimes it helps, actually I'm going to erase that, sometimes it helps to write the function over again. Remember, they're asking you to find f of n. So what that means is they're asking me to take this and they're asking me to plug it into here and into here. So what that looks like is n squared plus 4n squared plus 4n squared plus 4n here. So now let's go ahead and FOIL this out. This is n squared plus 4n times n squared plus 4n plus 4 times n squared plus 4n. A little bit of math here. N to the 4th plus 4, 8 of them, 8n to the 3rd plus 16n squared plus, distribute this in, I get 4n squared plus 16n. So now let's combine what we can. Those two can combine, so I got n to the 4th plus 8n to the 3rd plus 20n plus 16. That's a lot of junk right there. Any questions on this problem? Kylie?
What is 20n squared?
I'm sorry, thank you. All right. Let's move on to the next one. 21. Okay. Can I save 21 for last? 21 for last? Put a star next to it or underline it. Okay, 27. Find the inverse of each function g of x is equal to negative x cubed plus 2. When you are finding the inverse of a function, replace your f of x or g of x or h of x, replace it with y. And that equals negative x to the 3rd plus 2. Now, when you are finding the inverse, first thing you do is you switch x and y. So I get x equals negative y cubed plus 2. And now I solve for y. So I'm going to go ahead and subtract 2 from both sides. I got x minus 2 equals negative y to the 3rd. I'm going to multiply everything by negative 1. So I get negative x plus 2 equals y to the 3rd. And now I'm going to take the cube root of everything. So I get y equals cube root of negative x plus 2. Any questions on that problem? Zoe, how you doing? Good, you got this okay? All right. Yes. Sorry about that. Duh? All right. Okay. All right. So that was number 27, I believe. Okay, 54. Ah, this problem. 4u minus 6 over u2. Good band, by the way. All right, so first thing I'm going to do, this is a complex fraction. I'm going to find a common denominator on bottom. So don't think too hard. The common denominator, anyone know what the common denominator here is? Don't think too hard, please. Let's see. Kylie, you know what the common denominator is? On the bottom here? Bottom. There you go. 2 times 2u minus 3. So I'm going to find that this is missing a 2u minus 3. Top and bottom. This is missing a u. I'm just kidding. It's missing a 2. So what I get on bottom now is everything is over 2 times 2u minus 3. I'm going to distribute this in. I get 2u squared minus 3u minus 2u squared. And don't forget there's a 4u minus 6 up top. Now the 2u squared and the negative 2u squared, they're going to cancel each other out, which is kind of neat. And now what I've got is 4u minus 6 over negative 3u over 2 times 2u minus 3. What's going to happen is that this thing is going to parachute up to the top like this, and I get 4u minus 6 times, I'm also going to flip these. Danny, am I? Ah, thank you. So this should be over u, right? Thank you. Times, let's see, 2u minus 3 over negative 3u. That's right. This problem doesn't simplify very well. So what I'm going to do from here is I'm actually going to factor out a 2 up top. So I get a 2u minus 3 over u times 2 times 2u minus 3 minus 3u. Now, I thought that a lot of this stuff was supposed to cancel itself out, but it's not going to. So we have to just multiply this thing straight across. So 2 times 2 is 4. 2u minus 3 times 2u minus 3 is 2u minus 3 squared over negative 3u squared. Now, it is my understanding that the answer key has something a little different. That's because they actually took the time to FOIL this out, multiply in the 4, and simplify it. Just leave it like this. Okay? This is good enough. Okay. Danny, thanks for catching that. Okay, that was 54. Let's go to 63. Oh, we are also going to do some inequalities today. All right, so the sign chart. So we'll do a few of those. Hopefully you guys brought your sheet, and if you didn't, we'll do them on the video, and then we'll also you will also do them as part of your review. I am solving a rational equation, which means after I find a common denominator, what can I do with all the denominators after I'm done? Jake? Cancel them all out. So, Jake, do you know what the common denominator is between all three of these terms? 6. You're thinking too hard? Just 6n squared. So, this thing already has it. What does the middle and right term need? Kind of. Kaylin? An n. So that's all gone. Whoops. So what I get is, since this got multiplied by nothing, it's 1 equals n squared minus 2n, n squared plus 3n. Alright, so let's combine some like terms here. This is 2n squared plus n equals 1. I'm going to subtract 1 from both sides. This is 2n squared plus n minus 1 equals 0. And now I feel that these can be factored. So I say 2n and n, it's a 1 and a 1 because of the 1 right here. And then, let's see here. I need to create a positive n, so it's going to be positive 1 here and negative 1 here. So n equals 1/2 and negative 1. But let's run it across our domain real quick. What, the domain?
No, 1 minus 1. Oh, sorry, it's 2n. Okay.
So n cannot equal 0 here. So none of our answers seem to run into our domain, so we're good. All right. 63. That was 63 right there, right? 64. Who asked for 64? Do you need that one still, Alan, or no? No? Okay. 72. Who asked for 72? Who asked for 72? Nobody? It just appeared up there, huh? Okay. Well, I guess we'll pass it over and we'll go back to 21. Okay, 21. Okay. Funny thing is, I didn't even think to do this until I spoke to Mr. Jenkins, and he gave me a pretty good idea, and actually it's pretty obvious. I can't believe I didn't think of it. Some of these, remember, when it comes to finding what the inverse of a function is, remember we would do like g of f of n if that equals n, or f of g of n, and that equals n, then the answer would be yes. Everyone remember that? Okay. If you end up with a really nasty problem like this, sometimes it's easier just to take the inverse of that problem and see if it works. So why don't I take the inverse of this bottom function right here? So if I say y equals 2 times n minus 3 to the 5th power, let's see what happens if I take the inverse. Do I end up with the top equation? Let's find out. So I'm going to switch out n equals 2 parentheses y minus 3 to the 5th power. I'm going to divide by 2. I'm going to get some junk down here. How's it going? Can you give me 1 second? So I got n over 2 equals y minus 3 to the 5th power. I'm going to take the 5th root of both sides. So I've got the 5th root of n over 2 equals y minus 3. Is this looking like this? Are they looking the same? No, so the answer is no. Right? So if we do another problem, because I know yesterday we ran into some problems like with number 22. All right, sorry about that. I had to fix this problem here. So let's go ahead and find the inverse of the top function. So that would be y equals 3 minus 2x over 3. I'm going to switch out x and y, so I get x equals 3 minus 2y over 3. Let's multiply both sides by 3, so I get 3x equals 3 minus 2y. I'm going to go ahead and subtract 3 from both sides. Remember, I'm just isolating y. That's all I'm doing. So I get 3x minus 3 equals negative 2y. Divide by negative 2. So what I get is, let me scroll back up here so that way we can check, y equals 3x minus 3 over negative 2. Now, does this, in fact, do these two functions, do these two functions actually match? Let's find out. Because they almost look similar, right? But they're not quite the same. Let's see what happens if I parachute this negative up top. I'll get a y equals negative parentheses 3x minus 3 over 2. And if I distribute that negative in, I'm distributing this negative in, I end up with negative 3x plus 3 over 2. Do they match now? Yes? So what is the answer? It's yes. So actually, I would say for these, which are fair game for the final, if you end up with a really complicated looking two functions and you have to figure out whether they're inverses or not, just find the inverse of one of them. If it matches the other one, the answer is yes. If it's not, then say no. Don't try to compose something like number 23. It's a nightmare. All right? Yeah.
What's the other way of doing this?
The other way of doing it is disgusting. So, let me see here. Or at least this particular problem. If we do the same problem,
Or is this just the way you're supposed to do this problem?
well, no, you can do this using composition, but you're going to have a really hard time. F of g of x. You're trying to make sure that this equals x. So f of g of x is going to be 3 minus 2 parentheses, let's see, 3 minus 2x over 3. See, I'm already getting lost. That's not correct. It would be this. So negative 3x plus 3 over 2. Actually, this one's not that bad. All over 3. Those are going to go away. So you end up with 3 plus 3x minus 3 over 3. Those go away, those go away. You end up with x. But y'all, take a look at a problem like number 23. That's pretty messy if you try to compose those two. Okay? So anyway, that would be my strategy for it. So, with this problem here, what you have to do is you have to identify each of these as fractional exponents. Jake, what's going on?
It's not a 5. It's a little 3.
Oh, it's a 3. I'm sorry. Thank you. 3. Fix that. So what you have to do is you have to convert these into fractional exponents. This is really x to the 2/3 minus x to the 1/3 equals 4. And don't forget, there's a 5 hanging out here. So now I'm going to go and subtract 4 from both sides. 5x to the 2/3 minus x to the 1/3 minus 4 equals 0. Now, can we factor this? Of course we can, because 1/3 is half of 2/3. So what we do is we write this in quadratic form. So it's x to the 1/3 squared minus x to the 1/3 minus 4 equals 0. And now, inside, I get 5x to the 1/3 and x to the 1/3. All I need are two numbers that multiply to 4 and add to 1. I'm going to say it's a 4 here and a 1 here. Let's just check. I got a 5, I got a 4. That can get me negative 1 as long as 5 was negative. Okay, so what do I got here? I've got 5x to the 1/3 plus 4 equals 0, and x to the 1/3 minus 1 equals 0. Let's go and add 1 to both sides. This side is easier, so x to the 1/3 equals 1. I'm going to cube both sides, so I get x equals 1. Here I get 5x to the 1/3 equals negative 4. Divide by 5. A little bit of algebra is a little quick. X to the 1/3 equals negative 4 over 5. Now, it's a 1/3 power answering in a negative. That is possible, so don't write no solution from here. I'm going to cube both sides, so I got x also equals negative 4 squared is negative 4 to the 3rd is negative 64 over 125. All right, so those are your two answers for that one. Let's do another one. Let's do something like number 21, which is y to the 3rd minus 8y to the 3/2 plus 16 equals 0. It is factorable. because 3 over 2 is half the size of 3. So I'm going to say something in parentheses being squared minus 8y to the 3 halves plus 16 equals 0. So I get y to the 3 halves. And again, you can always double check. You just multiply these two together, you get y to the third. So now we get y to the 3 halves and y to the 3 halves. Minus, looks like it's going to be 4 and 4. Well, this is kind of cool. We don't have to do much for it. Y to the 3 halves equals 4. Now, I am going to take each of these to the third power, to the, what do you call it, whatever this thing is, to the 2/3 power. Huh, this is kind of odd. Y equals 4 to the 2/3 power. Now, you can't take the cube root of 4 without getting something really kind of nasty, so just leave it as this, or you can convert it to the cube root of 16. All right, because it's the cube root of 4 squared, and 4 squared is 16. All right, let's do a couple of sign chart problems. Let's start off with a little bit easy, and then we'll jump forward to something a little bit more difficult. How about something like number 37? Okay, it's already factored. Everything is simplified, and it is greater than 0. There's a 0 on the other side. So from here, we can jump straight for those critical numbers. Now, remember, we were identifying critical numbers up top and on bottom. So the critical numbers up top were 0 and 1. The critical numbers on bottom are 3. Any questions so far? Brother, how you doing over there? Good? Okay. Cool. I wasn't trying to call you out. I'm just asking how you're doing. You're not gonna punch a refrigerator or anything? Okay, good. All right. From here, once we get critical numbers, we put them in a sign chart here. So it's gonna be 0, 1, and 3. Let's partition it downwards. So I've got an x minus 1, and an x minus 3. Before 0, let's choose a negative trillion, so it's going to be negative, negative, negative. Between 0 and 1, let's go 1/2. 1/2 is going to be positive. 1/2 minus 1 is negative. 1/2 minus 3 is negative. Between 1 and 3, let's choose 2, so that's going to be positive, positive. 2 minus 3 is negative, and then 5 trillion is going to be positive, positive, positive. So this gives me negative, positive, negative, positive. Which intervals am I interested in? Zoe, what am I interested in?
Positive.
The positive ones, because I'm looking for things that are greater than 0. So now I need something in interval notation. So I'm locked between these two, so that's between 0 and 1. And I have a union symbol because I have to jump over the negative, and then I will end at 3. Rather, I will start my next positive interval at 3, and I will end at positive infinity. Now, because I am not including anything, everything gets a soft bracket. Any questions on this problem? Is this pretty doable? Yeah? Cool. All right, let's do something a little bit more challenging. How about something like number 50? Okay, so 1 over x plus 2 is greater than or equal to 1 over x minus 2. I'm going to subtract 1 over x minus 2 from both sides. Now, here's where a lot of people started making a mistake on the quiz. I'm going to cut this off here. 1 over x plus 2 minus 1 over x minus 2 is greater than or equal to 0. From here, a lot of people started finding critical numbers right off the bat. What do you need to do before finding critical numbers always? Danny? common denominator. So common denominator here is x minus 2, x plus 2. So this needs an x plus 2. This needs an x minus 2. So this is going to be x minus 2 minus x minus 2 all over x plus 2 times x minus 2 is greater than or equal to 0. X minus x goes away. Negative 2 minus 2 is negative 4 all over x plus 2 times x minus 2. Now that it's all simplified and nothing else can be combined or anything, now we can find our critical numbers. Elliot, do you know what kinds of critical numbers we have here? You don't know? What kind of trick is this, Elliot? Okay, just kidding. Let's see here. What are the critical numbers on bottom? What are the critical numbers on bottom? Yell. 2 and negative 2. Are there any critical numbers up top? None, because there's no x's up here, right? So just none. So let's go ahead and bust this thing out. This is negative 2, 2. Partition it downward. Negative 4, x plus 2, x minus 2. Now negative 4 is easy because negative 4 is always what? Negative. Let's choose a number way before negative 2, so negative trillion, that's going to be negative, negative. In between negative 2 and positive 2, let's choose 0, so that'll be positive and negative. Beyond 0, let's choose 5 trillion, positive, positive. So my final intervals are negative, positive, negative. Which interval am I interested in? Kylie, what am I interested in? Positive, right? Because this thing is greater than 0, so I'm here. So now my intervals are between negative 2 and 2, and that's it, because I don't have a union. I'm not jumping over anything. There's the chance for inclusion, but my critical numbers are on bottom, so that means I can't include any of my critical numbers. Duh? All right. Let's do one more. Let's do one that's a little bit trickier. How about something like 55? So I'm going to subtract 8 over x plus 2 from both sides. So I get x over x minus 1 minus 8 over x plus 2 is less than or equal to 0. Now, find a common denominator. This side needs an x plus 2. This side needs an x minus 1. So what I have is I have x squared plus 2x. That goes away. Negative 8x. Positive 8 all over my common denominator. Less than or equal to 0. Let's combine some like terms here. That's negative 6x. I'm going to refactor the top because I can and because I want to. So that would be x minus 4 times x minus 2 over x minus 1 times x plus 2. Less than or equal to 0. Everything is simplified. Everything is all isolated. And we got a 0, so we go straight for critical numbers. Critical numbers up top are going to be 4 and 2. Critical numbers on bottom are going to be 1 and negative 2. Into the sign chart they go. Negative 2, 1, 2, 4. Alright, so now my functions were x minus 1, x plus 2, I believe it was x minus 4, and x minus 2. Okay, so negative 5 trillion is going to give me 4 negatives. Between negative 2 and 1 is 0 is going to be negative, positive, negative, negative. Between 1 and 2, 1 and a half, positive, positive. negative, negative. Between 2 and 4, let's choose 3. So positive, positive, negative, positive. And then 5 trillion is going to give me 4 positives. So I've got a positive, a negative, a positive, a negative, and a positive. I'm looking for where this thing is less than 0, so which intervals am I looking for? 70! Negative intervals. So that means that my answer is going to be between negative 2 and 1, union, because I got to jump over, and then 2 and 4. Now, there is the chance for inclusion here. My critical numbers on bottom were 1 and negative 2. So 1 and negative 2 cannot be included. Everything else can be. All right. Very cool.